Hello everyone, welcome to my YouTube channel one more time again. So today I want to discuss problems from this round's Harbour.Space scholarship contest 23-24 Div 1 plus Div 2 ABC problems. First of all, problem A, increasing and decreasing. So you are given three integers x, y and n. Your task is to construct an array consisting of n integers which satisfies the following conditions. So the first element should be x and the last element should be y. A is strictly increasing. That's not equal to or greater, that's exactly greater. So if we denote B, that's I plus 1 minus AI, this should be strictly decreasing. So if there is no such array A, print a single integer minus 1. So here, as you can see, we need to construct such array A that so first element should be x and something A2, A3, A4 till then, and last one should be y. So also A2 minus x, this is array B, let me call this A and B. We have also this such an array B that I plus 1 minus AI, so that's first one would be A2 minus x, second one would be A3 minus A2, and A4 minus A3, and so on, and this y minus this last A for 4, let's call it 4, and remove this. So that this part should be increasing, and this should be decreasing. So now let's see these examples. For example, here what we have 1, 3 and 4. So this 3 minus 1 is 2, 4 minus 3 is 1, so it's 2 and 1, and if we add them it's 3. So now when is the minus 1 case? When it's 3 is this. How we can find this 3? If it is bigger, for bigger numbers, it can be 3 plus 2 plus 1. That's the minimum numbers we need. So here y minus x is 3, y minus x is 3. In that case, I mean this case. So how we can calculate that minimum numbers to make this array? So for example, for this array, this is choosing minimum numbers because y is 4 and x is 1, and we need to construct of one array of 3 elements. So there is no other case than putting 3, because this should be 2 and this should be 1. This should be array B should be decreasing. So the minimum number of minimum numbers we can get is 2 plus 1 here for 3 arrays, and for 4 arrays it's 3 plus 2 plus 1. So that comes to n times n minus 1 divided by 2. So in that case 3 times 2 divided by 2 is 3. So if this is bigger than y minus x, answer would be absolutely minus 1. Otherwise we can construct it. If otherwise, so if that's not the case, we can construct this array. First we put x here, and then we check. So if they are equal, so we will check if they are equal, it wouldn't be the problem. We can put just 3 2 1 if it's just 2 1, but if it's for example 5, then we need 4. Instead of putting 4 2 4 3, if it's 4, then 3 2 1, it should be actually 3 2 1, but we have 5, we need to use, otherwise we cannot go to y. So that's why we can add 1 here. So we can calculate it. We need extra y minus x minus this n times n minus 1 divided by 2, and x, and the second element would be x plus extra plus this n minus 1, and other elements would be x plus n minus 2, x plus n minus 3, and so on and so forth until we reach y. So it's not actually x plus n minus 3 itself, this is x plus this value. We will update x's value. For example, this was previous x, this would be second element, and the third element would be even bigger, this plus this. So we can just avoid this kind of thing by keeping adding x every time we do any operation. For example, in the first operation we can add extra and n minus 1 to the x, so we don't have to care about it in the next operation, so we can just take it as x itself. So now let's discuss how to implement it. First, you should yourself try to implement it by yourself. If you have any issues and you don't understand something, you can check it with my code here. So I just checked this case. So I firstly checked this case, and if it's minus 1, I just returned. Otherwise, as I said, we need to find what's extra. After this, we can put starting points here. The reason why the starting point is minus 2, because in the first place we are printing minus 1 directly, so that's why we don't have to care so much. So after this, we can every time print x plus this star, and we can subtract 1 from it, and every time we need to add this variable to x. So if you do this, you will get accepted. So now we will move on to the problem B. Problem B, swap and reverse. You are given a string as a length of length n consisting of lowercase English letters and integer k. In one step, you can perform any of the two operations below. Pick an index I and swap si and si plus 2. So pick an index I under these constraints and reverse letters formed by I and I plus k minus 1 of the string formally. If the string currently equal to this should be changed to this. So we can do any number of operations, and we need to smallest string. So it's the smallest string. So let's discuss what the operations are doing. So no matter what the case value is, for example, we have this, we can always change the places of the ones that are, for example, in the odd places, n and n. In the odd places we have n and m, and in the even places we have I am talking about indexes starting from 1. So no matter what the value of k is, by using k and first and second operations efficiently, we can always sort this and sort this too, and put the this for example, when odd one comes, we can put the one sorted odd 0. This I'm talking about sorted odds, and even 0, and odd 1, and even 1. So overall, I'm talking that we can get odd and even positions separately and sort them and add them together, no matter what the value of k is. But if k is this if k divided by 2 is 0, I mean if k is even number, we can solve this as string s wholly. So just we can sort the string s fully. I mean, for example, if it's an IMA, we can just sort it. We don't have to care about any operations. So the implementation would not be that much of difficulty if you have this idea. So overall, if k is odd, we will do this operation, otherwise we can just sort it. So here what I'm doing is that if as I mentioned, if it's even, we can just sort it and print, otherwise we get odd and even separately, and every time we add if it's odd, we will add it to the odd string, and otherwise even string, and we will sort both of them. If you have any problems, you can just see how to check what's going on to see and understand it better, and every time we will print just one number, and that's it. So let's go to the problem C. So divisor chain, you are given an x, your task is to reduce x to 1. To do that, you can do the following operations. Select a divisor of x, that then change x to x minus d, reduce x by d. We say that d is a divisor of x if d is an positive integer and there exists an integer q such that x equals d times q. There is additional constraint, you cannot select the same values d more than twice. For example, the value of 5 goes like this. So we are given one n number, and we need to find its one divisor except itself, of course. If we can subtract it itself, and then it becomes 0, but we need to do it 1. So to do it, for example, if it's 3, we can do it to 1. For example, here for 14 they did this way, but we can do other way around. For example, 14 we can subtract 2, it would be 12, and we can subtract 4, it would be 8. We can subtract 4 again, this would be 4, and we can subtract 2, so this would be 4 minus 8 minus, we subtracted 4 and it became 4, we subtracted 2, so we can just subtract 1 now, and answer would be 1. So as you can see here, what I did was simple. I found this biggest power of 2 that is not equal to the number itself. For example, for 8 I didn't choose 8 because this would be this could lead to answer being 0, but we don't want this. So this I found the bigger 2 of n that satisfies this 2 of x, because this number calling n, this is smaller than smaller than n, and at least 1. So I mean 1 is also power of 2, that is power of 0's power. So overall, if we do that, we are not getting any value twice. So that's really interesting, and this was the idea of the problem. So in that way we can do it this way. The implementation would be like this. At first we will put n itself, because it should start from the beginning, and then every time until this becomes 1, every time we get 2 at first, and if I is small, while I is smaller than I, if it's divisible by is not divisible by 2, we just break it and subtract I divided by 2, because at first we got 2 from nowhere to check if it works or not. Every time if it's still divisible by 2, we just multiply it by 2, and at the end we print the length of this vector and every element in this vector. And if you do so, this your code should pass this test cases. So try to implement it yourself. If you have any problems, write comments about it, and follow for more. Goodbye.